Okay, so welcome everyone to the Developer Summit. My name is Martin Bradley from the Wearables and XR strategy team here in ARM. And in this session, we're going to be talking through one aspect of the development of the fast-growing smartwatch market, which is the potential for machine learning to play a role in realizing the capabilities of these products over the next few years. The smartwatch market is essentially based around a product which has grown rapidly since 2015, initially as an accessory to a smartphone, but increasingly as a autonomous, communications and computing device. And ML can play a number of important roles in the development of the smartwatch market, drawing insight from the integration of sensors through to power-efficient solutions for audio processing, through to delivering some of the camera-based use cases we've seen on smartphones as that technology cascades down into wrist-worn computing. And given the highly personalized nature of the biometric data collected and processed on smartwatches, it's likely that the security and privacy expectations of the market will be best provided through machine learning undertaken locally on the device. So in this panel session, we'll be discussing a number of aspects about the realization of ML on these new devices, from use cases through to the software algorithms, neural networks, and then the system requirements, touching on performance, power management, connectivity, security, and privacy. So today I've been joined by three industry leaders from different parts of the wearables ecosystem. And I'd now like each of my guests to introduce themselves, including their company and role. And then we'll move into the discussion part of the session. I'll be acting as a question master, as well as offering some of the perspectives from the types of activities we're doing in this market segment. So, Pankaj, can I ask you to kick off?
Yes, thank you, Martin. Good morning, everyone. This is Pankaj Kedia from Qualcomm, calling in today from San Diego. I had the privilege of starting the wearable business for Qualcomm over 5 years ago, and now continue to lead it, grow it, move it forward. So I'm looking forward to sharing what we are doing to bring next generation wearables to the market. Back to you, Martin.
Thank you, Pankaj. Scott, would you like to go next?
Yeah, sure. My name is Scott Hanson. I am founder and CTO at Ambic. Ambic is a company that's putting chips everywhere. We're attempting to enable intelligence everywhere, as we like to say. And we're doing so by providing the world's most energy efficient chips. And everywhere, as you might expect, includes on the wrist. So today we're shipping in many millions of units per month of wearable device. And what we enable our customers to do is compute more, do so with less energy, that enables smaller, thinner batteries, new battery lives, et cetera. So like Pankaj, I'm excited to be here. Thank you.
Thank you. And Adrian.
Hi, everybody. Delighted to be here. My name is Adrian Condon, and I am co-founder and CTO for our company, BeSecure. So BeSecure are a scale-up company developing cutting-edge biosensing health algorithms and analytics that we license to other technology companies, including some well-known brands you will be familiar with. Our primary licensing comes from consumer wearable space, especially since we achieved FDA clearance for our technology. But increasingly, we're doing business with traditional medical players, and we see that consumer and medical are continuing to merge to meet demands such as remote patient monitoring, which I'm sure will be discussed later. Our technology combines traditional diagnostic features such as atrial fibrillation detection, but we also have a range of wellness features such as stress, fatigue, etc. And we see a future where health management is actually prevention rather than reaction. And we feel our technology enables this. We've been working closely with ARM for many years to ensure our technology will work with the cutting edge of silicon development that ARM continue to deliver. I'm really excited at the latest features that are in development. Thank you.
Thanks, Adrian. Great. So let's kick off with the use case that we started to outline at the beginning of the session there. And consumers, clearly got growing expectations of smartwatches as a product in this category, and the use cases for those wearables has tended to increase massively from where it started, with fitness tracking through to more advanced health and mobility capabilities, also functions that improve the convenience of daily life of people. So the package of capabilities, it has really started to expand. And the number of third-party applications as well is really very extensive. And that's certainly something that is embracing a whole range of new sensors, ECG, electrodermal, oxygen, pressure, vibration, movement. So one of the applications of this, and you can see the way the trend is moving, is that rather than taking just individual data metrics from a product like a smartwatch, whereby it's measuring, say, heart rate only, or one particular parameter that is then kept in isolation. What we're seeing is the tendency for these sensors to be integrated and then to infer insights for the individual, for the user, about what the state of the health of that person, and it's right through to nutritional recommendations in the future, whereby the combination of all those capabilities can provide real insight that can deliver those end user benefits. So I just wanted to sort of go around the panel here in terms of getting thoughts on the health and telemedicine aspects of the way this market is evolving from a use case point of view. So Adrian, do you want to kick off with that one?
Sure, yeah. I think we're seeing the merging of two major industries, your traditional consumer and your traditional medical. We've got traditional medical devices which are focused on a clinical environment, and then most recently we have smartwatches which are increasing in complexity and capabilities and accuracy more than anything else. And we've come a long way from a step count. As you mentioned, Martin, we're loading these things up with much more sensors, and the really exciting thing is that our bodies are all different, and these smartwatches and their capabilities and the analytics that come off the back of them really open up a window into what is going on with your body. And as you mentioned, that ability to be able to really understand how your lifestyle impacts your body and then measure that accurately and then build a more preventative type of feedback to the user is really, really exciting.
What's your sense, just from the use case point of view, before we get into the applications?
Yeah, so I see three use cases that are really exciting for me. The first is what we just talked about. It's the on-device health monitoring, health coaching. And today it's I would say it's very open loop. Here's some data that tells you a little bit about your health, but we don't necessarily close that loop and say, here's what you need to do differently in order to improve your health, right? So there's an opportunity there. The second big one is on-device fitness coaching. So this is different than the health angle in the sense that, hey, I'm a runner, I want to become a better runner, help me become a better runner. I'm getting to the point where my watch today will suggest a workout. I'll go out and start my run and it'll say, hey, maybe today you should do 5 miles at XYZ pace, right? That's a good start, but it's not where we need to be. We've got so many data points that we're capturing every second in these wearables. We need to make some decisions with that data. We need to deliver insights back to the user. And then the final thing I'll mention is better, more intuitive UI. So this is a little bit different than the health angle, but wearables are just fundamentally difficult to interact with, right? They're tiny. Even on these really rich displays that say Pankaj and his company are enabling, it's still small, right? It's much smaller than the phones. I mean, if we look at phones, they've been moving towards bigger and bigger displays. On-device endpoint AI can enable much more intuitive UI. So think voice interaction, think gesture-based control, think even simple things like maybe I don't need to interact with my watch at all. Maybe it detects, hey, Scott's going for a swim, and so I'm going to activate swim mode without being told to do so. There's all kinds of context information that we can extract from the sensors that are on board today. We're just not doing so, right? We're seeing it happen more and more. And part of the discussion here will be, well, what do we as the enablers of this ecosystem need to provide in order to make all this possible? But those are my three things: health coaching, fitness coaching, and then better, more intuitive UI. I'm very excited about all three.
So Martin, I'll jump in. I agree with everything that Adrian and Scott said. The way we think about this, it's the convergence of what consumers want and expect, what the fitness medical community wants to deliver or needs to deliver, and what the technology can enable. Number one, always on. When you think about always on, it needs to be always accurate at super low power. Number two is, Scott, when you talk about fitness coaching and health coaching and so on, then many different types of sensors. Knowing who you are, where you've been, knowing where you're going next, there's a lot of data that comes together that needs to be showcased in this small screen that Scott mentioned. So number two is natural, intuitive user interface. Actually, that requires a lot of performance. Performance to compute all of the sensing, performance to overlay different types of trends and graphs and so on, performance to aggregate where I've been, where I'm going, who I am, who my friends are, being able to convert that data into information. And number three, what I would say is, as more and more data is in the cloud, there is no such thing as offline mode. You have to be always connected. In summary, the use cases Adrian and Scott are describing are right on. We have to do it always on in a rich, intuitive, immersive UI, and while always connected.
In terms of ourselves, what we've been trying to do is take one of the most incredible signals from the body and effectively try and capture it off everyday IoT devices. If you think about that ECG signal or EKG signal, it's full of such rich diagnostic information about the body and its state, not just whether you have a heart condition or not, but your stress levels, your fatigue levels. We even can identify you through your ECG for the personalization aspect.
Also, I think users are very aware of the degree of insight that the smartwatch is actually able to obtain that's over and above anything that you can obtain on a smartphone, because those sensors are constantly on and tracking your activity. It's able to obtain much more personal and insightful information than a smartphone. And yet, if you start to sort of combine all of the applications environment on the smartphone as well, then you end up with this incredibly powerful product that I do wonder, do consumers need an assurance about the way in which the product will always work for them? Do you think that smartwatch actually represents an infinite technical challenge for the future? If you're thinking 5-10 years ahead, where will the balance between performance and user experience actually end up? is it always going to be, you know, the next few years we can achieve the next level of battery life, or you know, increased functionality in certain experience dimensions? It really seems like an infinite runway. Any thoughts on that, Scott?
Yeah, so I'm on the optimistic side. I'm sitting here providing hardware for this space, and I very much believe in the long roadmap that we have forward. Some of that is driven by Moore's law, as the phone industry has been. Some of it is driven by the roadmap of innovations that we expect to bring to bear at the hardware level, at the software level, at the algorithm level, at the application level. So yeah, I have every bit of optimism that we're going to be able to continue to increase performance without compromising battery life for a very long time. And I think that latter part is important. Yeah, unlike, say, a data center environment, unlike even a phone, we have pretty wild cost constraints. So you can't throw a $125 processor inside of a watch. And we have really unprecedented power constraints. You can't strap you know, a Tesla-sized battery to your wrist, right? So the good news is, I think that we can still sit within this, call it 50 milliamp hour to a couple 100 milliamp hour battery, and continue to deliver massive increases in performance in the coming years. And I think some of that will come from, as I said earlier, Moore's law. It will come from TSMC and the other chip manufacturers coming with better technologies. It will come up with it will require companies like ARM to deliver better processors. It will be up to companies like Qualcomm and Ambic to use that ARM IP to build something bigger and better than they had before. And then the whole stack of software and applications that's sitting above it has to be better. One point I want to make actually on this PowerPoint, though, is it's a complete system problem, right? I think we have a tendency right now, AI is the sexy thing, right? It's the shiny penny. And so everyone's talking about how many teraops do you have? Or maybe they're talking about how many teraops can you fit in a 1 watt power budget, or how many gigaops can you fit in a 1 milliwatt power budget? But the truth is, if you break down your typical endpoint AI system, your typical watch-based system, you have a microphone maybe that's collecting audio data, and that's consuming a couple 100 microwatts. You have an ADC that's converting that to digital. Maybe you have some pre-processing that includes some decimation, some filtering, maybe conversion of frequency domain. Only then do you have your inference. And then you've got a whole bunch of other stuff that involves security, involves packaging up data for communications. And then, as Pankaj mentioned earlier, you're always connected. So you're transmitting that data, even if it's just a decision, not the raw data, but a decision. Did I hear the keyword Alexa? I'm still transmitting that up to a phone or a cloud. So I think that we have to innovate. We have to enable the next 5 or 10 years. There's plenty of roadmap, but we have to do it across the full signal chain.
Yeah. Well, that's very well put. Pankaj, would you add to that in any way in terms of the technical challenges, the opportunities?
What I would say is, you know, we are still in phase 1 of wearables. In phase 1, what happens is the applications that were created, or the user experience, or the content that was created for the smartphone, is adapted for the smartwatch. Phase 2 would be when applications are written first for wearable. I'll give you an example. You know, the same thing happened when we went from a laptop to a smartphone. The first applications were miniaturized laptop applications. And then Uber was created. What came first, Uber or smartphone? If smartphone did not exist, Uber wouldn't be here. And Airbnb would not be here. And Snapchat would not be here. And TikTok would not be here. And so on and so forth. So while we deliver the right performance in the power and size and security envelope, we live in a platform age. The platform, the ecosystem is innovating on applications and content and services that are uniquely designed for this. And that game has barely begun. But the user experience is what the consumer buys. And there, the industry innovation, the ecosystem innovation, we haven't seen anything yet. I think the best is yet to come.
One thing we're very conscious of is that in the academic environment, quite a lot of study has been undertaken into, the analysis of signals associated with audio processing, and it's a very extensive subject, which is sort of heading in our direction, really, in terms of being incorporated in wearable devices. So even though this type of investigation sounds exploratory at the moment, within a couple of years, it's going to become one of those use cases. Perhaps that everyone starts to rely on. So yeah, I just wondered whether you had any thoughts on the sort of beginnings of a new level of complexity that we're going to have to take on board with the kinds of sensors that will emerge on these devices.
But as you pointed out, we're doing basic keyword detection. The next level is let's call it emulated NLP, where you give the look and feel of natural language processing by recognizing 100 different commands, and maybe there's only 10 different things that we're trying to recognize, but there's 10 different ways to say each one of those things. So you get emulated NLP, and we'll eventually get to NLP. I view audio as a precursor to video. So, you're kind of processing in one dimension, and all of a sudden we're going in 2 dimensions, right? You've got with audio, it's a one-dimensional time series. Now I've got a 2-dimensional time series in vision. So what I see us being able to do in the very near future is conquering audio. And I see a lot of fabulous use cases for audio, both as a UI mechanism, as well as maybe a health and fitness coaching mechanism. And then I'm excited about where we go with vision, and it's yet another sensor that tells me what's going on in the system, right? It tells me what the user is doing. It tells me what the people around the user are potentially doing. But it's clear that that's a big compute problem, and we're not there yet. But I'm going to echo the optimism that we had a second ago. I trust that we'll conquer that. So I think let's conquer audio first. That's one level of complexity that I think is within our sights. Then vision comes next, and I think there will be really exciting use cases there. So I guess you're asking, are we ready for the complexity of all this new sensor data? Yeah, I think we are to an extent, and we have plenty of dry powder in the chamber, so to speak, to take on the next level of challenge.
Martin, let me build on that. Scott, as you mentioned, from audio going to video, going to camera-based use cases. Camera-based use cases are coming. They are very successful right now. They are the flagship experience in China for things like short video calls, or using the camera to do real-time translation, language translation, or image detection. Those experiences are coming to the US and Europe as our communication goes from audio to audio plus video, like we are doing here. This guy is not going to escape, right? So, so it's very exciting times, and there is a lot of opportunity given the constraints we live in, given the resources we are constrained by, especially on the rest.
Yeah, that's certainly something that chimes with our perceptions here in ARM in terms of the expectation of consumers to incorporate that vision component into the product. We did some market testing and primary research around expectations of users by use case, and the camera really struck us as something that really seems to be something that people want, not only on the phone but also on the watch. Not everybody, but a significant portion of the market. So I was wondering, Adrian, the scope is kind of boundless, isn't it, in terms of the task ahead for yourself?
So yes, it's going to get more complex, and we are pushing the boundaries of what can be done, but it can be done. And I really like, I think Scott mentioned this, but this sort of system approach, you know, this sort of holistically look at a problem from a hardware, software, data security aspect. Certainly the customers we work with, we can't, the different companies here, we can't show up really anymore in isolation and say, hey, I've got really optimized hardware. Well, you need really optimized software. You know, so what we're seeing is more and more demand to show up with, you know, solutions. And I know the guys here and their respective companies are really focusing on that.
It's a solution problem. Wearables are really hard. Okay, they're constrained in multiple dimensions that other devices aren't. And so whether we're optimizing for privacy or energy or performance or inference or cost, it's going to take all of the people on this call, right? All 4 companies represented here have to work together. The other companies that are out there listening to this need to work with us, right? So I implore everybody, work together. Let's build a good cohesive solution that delivers that fabulous UI and UX that has been talked about here. So cooperation, that's my final pitch.
Yes, absolutely, absolutely. Well, with that, I'd very much like to thank the panelists today for very insightful perspectives on the market. It's been a great pleasure to host this today and discuss the themes, the industry, the trends, the way in which we can enable this exciting future to be realized. So with that, I wish you the best for the rest of the conference, and thanks again to the panel today. Thank you.
Thank you.
Thank you, Scott. Thank you, Adrian. Thank you, Martin.
Thanks, guys. It was nice chatting.